Hey everyone, Mr. Armitage here, again with the sick voice, but describing how to use the calculator to do our one proportion z-tests rather than having to do them entirely by hand. Now note, you will still need to check the conditions each time, but you don't need to figure out if you're doing like upper or lower bound or anything like that to find the p-value. Right, so let's take a look here. I'm using as our example the check your understanding from before. Okay, the one on the Flint water crisis. This check your understanding is about the teenagers hearing stories from their parents and grandparents. Okay, so we can see that our sample size, right, is 180. And we know as well, right, 40% of them had heard stories. Okay, so that means, right, 40% of 180 had heard stories. So 72. Okay, cool. We get a nice whole number. That's our value of x, the number of successes in this case. Okay. Now, we already know, right? That's our null. This is our alternative right here, that p is less than 0.5. So here's how we use the calculator. Okay, I'm going to show here on the TI-84 first, and then I'll show you on the TI Nspire. Okay, so obviously it's on right now. We press Stat, and we want to go over to Tests. Okay, this is just like when we did the confidence intervals. Okay, see at number 5, it says one prop Z test. I'll zoom in. One prop Z test. Okay, that's what we want to choose. And it gives us a lot of things here. Okay, this part here, this P0, okay, that's the value of our null hypothesis, effectively. Okay, that's the population proportion that we're dealing with. So in this case, it's 0.5. X is the number of successes, as we just found, 72. N is our sample size. There we go. Now, see how we have three options here for um, the alternative hypothesis? Okay, currently, well, you can see right now, currently it being greater is the one that's selected. Okay, so this is saying that the prop would be greater than the null, or greater than 0.5, but our situation was that we wanted to know if the actual proportion, okay, our alternative is less than 0.5. So that's the one we press, right? We highlight it and press enter, so it actually selects it, right? Notice when I move, okay, it stays with whatever it's selected, but it only changes once I hit enter. Then you can go down and hit calculate. And there you go. Okay, you have your Z, your critical Z, or not critical, sorry. You have your test statistic Z. This is negative 2.68. We got right, negative 2.7. Close. Very, very close. Okay, and here our p-value 0.0036. Okay, and we got 0.0034 for that way. And then p hat, it kind of looks like a hat on here. It's only 3 pixels. Okay? And then n again for some reason. Now, if you were to do that same thing and said the not equals, because now this makes testing this orange alternative hypothesis much easier. Okay, not equals, calculate. See the same thing, still the same z. Okay, this is the alternative hypothesis, and now 0.0073. Okay, close enough, right? We doubled something that we rounded. That's fine. So that is how you do a one proportion z-test on the TI-84. Now let's go ahead and look at the NSPIRE. Hey, I just grabbed this calculator off of the charging dock. Okay, this one, we go to Menu. Okay. Now we want statistics. Now notice there's the 6 next to it. What I really recommend is just pressing the number 6 rather than trying to use this. Rather than trying to use this thing, right? It just kind of freaks out and is weird, so I always recommend just pressing the number. Okay, stat tests, number 7. And then we see at number 5 still, one prop z test. That's 5. There we go. P0, that's our null value, 0.5. Okay, now we do have to press down. Success is X, that was 72. N was 180. And this one actually explicitly tells us what the null hypothesis is. Or not the null, what the alternative hypothesis is. Right, so we have to press the right arrow, and we see now we have several versions. So is our alternative saying that our proportion is greater than 0.5, not equal to 0.5, or less than 0.5? Now it says P0 there, but we put in 0.5 for that. So we want less. Now, enter. And there we go. Okay. One prop z-test. Okay, there's our alternative hypothesis. There's our test statistic z. This calls out the p-value, 0.0036. Same thing we got before. P hat is 0.4, so we know we did everything right there. And just to show that the not equals is just the same as we got before. Okay. Statistics, stat tests, one prop z-test. 0.5, 72, 80. Okay, it's already set for not equals, so we're fine there. Enter. Right. Same thing. The only thing that changed was the p-value. Okay, so see, it didn't take me all that long to do. So now we can actually do one proportion z-tests and all other statistical tests that we do really fast in this class. And we don't have to constantly like figure out lower, upper, all that fun stuff. There is one other thing you might have noticed. In this one prop z-test, okay, I'm doing the same thing on the 84. This is something that the 84 has that the NSPIRE did not have. Notice how it has this draw option. Okay, we did calculate because we want the numbers. Okay? If we go to draw, okay, it draws us a normal curve, and okay, technically it would show us where this particular z fell. Right? It would shade in. Not a great picture here, right? We exaggerated with ours, of course. Okay, but let's use a slightly different value. Okay, so we're just gonna, we can just press the clear button to get rid of this. It goes away. Let's use, instead of 72, okay, let's actually do something closer to about 47%. Okay, so you'll actually see, I did it on the separate calculator. When we did 47% times 180, we got a decimal. Okay, so we need to use a whole number. So we're going to just do 85 for x, just so you can see what it looks like. Obviously, this isn't what we would actually do unless the problem called for it. So let's look at this. Okay, See there? This part is shaded in. Okay, it does have limitations because obviously the pixels are gigantic on this, but we do what we can. All right, so that's how you use the calculator. Now we can finish multiple problems in one day. See you later.